There we go. Yeah, so we're here to learn a little bit about testing Java microservices. I'm Andy Gumbrecht. I am a PMC on the Apache TomEE project. I've been a committer at Apache for just over 10 years. I'm also a committer on the Eclipse Foundation for EE4J and the micro profile. And I've spent the last couple of years, and it has actually been years, on this little piece of work with my testing hero, Alex Soto, and Jason Porter, to produce this book, which there are some examples going to be floating around probably tomorrow. I think it's important to just get a picture in our minds as to what a microservice is. I'm sure each of us has our own individual opinion, and it is a very opinionated subject. So I did some research and came up with this really fantastic image. It's the surface area exposed by an endpoint. I didn't actually want an ice lolly, I was looking for an iceberg, because iceberg kind of paints that picture of it's that bit at the top, and underneath there could be this colossal application. So it's as big or as small as you want. It's a common misconception that because it's called a microservice, it's really tiny, and the image it provides is really tiny. The surface area they're exposing is supposed to be as relatively small to serve its purpose, and that's defined by you. So the idea behind a microservice is to make it scalable. It's to extract it possibly from a monolith, and I'll get onto that in a second. It doesn't have to be an SCS, a self-contained system. So some people get very angry when you say, something's writing to a back end of a microservice. I have a good example for that. I had to write a microservice for a log stash application. So log stash is being fed by hundreds of clients, and the service was basically an aggregator that filtered out sensitive information from the logs. So that's a good example of it not being a self-contained system. It's your party. The goal is basically just to test the beer. And for the sake of equality, wine for the ladies. So where does a microservice come from? We originated with this monolith, and I'm going to try to go through these slides as quickly as possible due to the lack of time we have. A monolith is just an application that's packaged all together and gets deployed to some kind of container. And everything's in it. So if we want to scale this thing, so this thing's getting traffic, and as the traffic increases and everything's under load, we start to identify the need for a new node. So we take the entire application and we clone that entire application and scale that. That can work in many scenarios, and it's pretty much the way things have been done up till now, so it's not like I'm going to stand here and say, don't do monoliths. Monoliths serves their purpose in certain areas. But we're here to focus a little bit on the microservice and why we need microservices from our monolith. So what we're doing is identifying some area of our application that is receiving a lot of that traffic. And it's become pretty much a bottleneck. So we've identified it, and we want to make it elastic. And the way we do that is we just extract that part of our application and make it basically a microservice. And then we can scale it. And the traffic is directed directly to the microservice, and our monolith continues to talk to our microservices, and that's this point in the middle. So basically here is where we need to start testing. So we've taken something out of our monolith application, and we've made a new remote microservice, and this is where the testing gets a little bit difficult. We still apply our testing pyramid, and I'm sure you're all familiar with the testing pyramid. Down the bottom, we have a large number of unit tests. So you've extracted a microservice. It's an application in its own right, and you should be unit testing every part of that microservice application that you're developing. Integration tests become slightly more interesting because now we've extracted ourselves away from monolithic application, and we have this microservice. And for example, we could have a microservice that is purely online. So we could be feeding, for example, from the Internet Games Database, a list of games, and we pull from that application information from our microservice. So testing against that is going to be slightly difficult, and we introduced this concept called service virtualization. I'll get onto that in a minute. And the final step is end-to-end tests. So we've broken things apart, and we now need to put everything back together. So we still have to do all the testing that we're familiar with. There's no new paradigm when it comes to the test pyramid. We're still going to apply all those things, but just in a slightly different way. And one of the challenges here is also going to be UI automation. I'm going to just go really quickly over these subjects. Each one of these could be hours long in their own right. So what I'll do is I'll name some technologies and pick an opinionated best of breed. So during the research that we did for this book, we decided we were going to use these particular technologies because we found them to be the best of breed. RestAssured is the first one. So we now have our microservice extracted, and we need to test our RESTful endpoints, and we're looking for something that's going to be helpful in testing our RESTful endpoint. So RestAssured is just basically a DSL that helps us talk to an endpoint and literally reading the text when, get, then. It's very easy to understand how to test an endpoint. If I just quickly pop over to their website, RestAssured. So just basically the scale of things, you can't do it real justice in a very quick talk like this one, but this is a nice example of the way we're testing RESTful endpoints. And we're going to be doing a lot of that for our testing purposes. And then we have this concept, service virtualization. Does anyone know what service virtualization is? Hands up, all those who have heard of service virtualization. No, which is good. So we're going to learn something new today. Service virtualization is the concept of basically talking to a service that is remote to us. So I am service A, and I need to talk to service B. What I need to do is capture the response from service B. The reason I need to capture the response from service B is because it's a service that's outside of my organization, and I can only talk to it under specific circumstances. And we introduce service virtualization, which is capturing the response. So when I talk to service B, it will respond to me. And this goes through a proxy, and I've picked this one, which is Hoverfly. There are various others like Wiremock. And what this is basically a proxy that sits in between your service and the remote service that you want to talk to or want to test against. And it captures that response. Once it's captured that response, it stores the response locally next to your test. So you would actually have that in your versioned local repository. What that means is you no longer need service B to be live to talk to. And you can ship that, and developers can download that, and they'll run a test, and they'll be running a test against this canned response that's been returned from this remote service. So the advantage of that is you can fire up a bunch of services that you wouldn't normally need or that you wouldn't normally have access to, capture those responses and store them locally. And this is done just very simply through adding a rule to a bog standard JUnit test. So nothing really scary about it. We take that a step further with contract testing. So virtualization is where we've captured this canned response from a server. And this is nice when you know this service is not going to be changing. But what happens if the service you're actually talking to is being developed by another team? And that's another fundamental reason for microservices. They can be independently developed by different teams. And so you have service A being developed by team A, and you have service B developed by team B. And team B, they're in the middle of development, and they're regularly changing stuff. And so anytime you've captured a response from service B using service virtualization, they're going to have to notify you. You're going to have to delete this locally captured canned response from service B, rerun the test against the real service, capture the response again, and then provide that for your developers. And contract testing just takes us a step further. And the main tool for this is Pact. It's kind of funny. On their front page, they have a nice explanation about what Pact is, a formal agreement between individual parties. As an example, the country negotiated a trade pact with the US. Well, as we know, nobody's negotiating trade pacts with the US right now, so just pick any other country you want. It's just an agreement between two different parties. And what this does is, this captured response that you were capturing through service virtualization, rather than store this locally, you store it on what they call the Pact server. It's an intermediary server, and service B, in their development process, so when they publish a new contract, it gets published to this central server. And in the same way that service virtualization will read this canned response, instead of reading it or trying to communicate with service B directly, it will communicate with the Pact server, and the Pact server has the latest version of the same contract. So you're still using a canned response or providing a canned response, but rather than capturing it yourself, Service B is pushing it to every time they change something to this server, and Service A, when it tests against the packed server. And so if they've broken that contract, if they change something, your test is going to fail, and you'll know instantly that you need to do something. Again, I'll just quickly swap to the... Not that one. So just to give you an example of packed, this is the tutorial, and there's the scroll bar at the top, and there is a whole bunch of code, and again, there's no way we could do this justice in just one talk. Packed is a presentation in itself. However, the reason we picked that is because there is so much documentation. It's very easy to go down and clone this repository and then carry on. So you can find everything at packed.io, so the URL is packed.io. Go there. The next stage, end-to-end testing. And this is where it gets really interesting. So we have our services, and we've extracted our services. And for me, these are the most important tests. They need to be done. They're at the top of our pyramid, so we don't want to do too many of them, but they still need to be done. And they basically test everything in place. They are the hardest to set up. They're very time-consuming. They're going to cost you quite a bit of resources to actually do these things. But for me, that kind of equals fun. I like to do them. They're very challenging, and I like a challenge. To help us do this, there's a really great tool out there, and this is one of these frameworks. You either know it or you don't. Hands up, who knows Archillion? Well, just one hand. No, a whole bunch of hands over there. So Archillion. Archillion is a Red Hat project. It was originally designed to test EE containers. However, it developed quickly to become way more than just EE containers. I use it for Spring Boot these days. And you simply add another one of these rules. So adding class rules to your unit tests is the easiest way of sewing these things in. And what they do is they allow us to add bells and whistles to your test and all sorts of functionality like database seeding and RESTful testing. So yeah, it's no longer for EE, it's a Red Hat project. It's another one of those projects that's very, very well documented. Just a little bit of fun, trivia fun. Archillion, if everyone remembers Men in Black, the Archillion was the bug in Men in Black, and the project is here to kill the bugs. So that's where that came from. Something else that I really like, I'm really grown accustomed to using now is BDD. Example on the right here, this is BDD in its simplest form, so we define features. Hands up who knows BDD and has used BDD regularly, or is one hand, brilliant. So you know how much fun they are. I like to say they're product owner-centric, so we all have our product owners giving us direction, and this is a way for your product owner to speak to developers using a language, a common language, and we actually call that a ubiquitous language, and we share this feature, and we can have multiple scenarios, and it follows the given when then paradigm, and it's very simple to read, and we'll be seeing some of this in a minute in a live code. You're going to be learning about cucumbers, gherkins, and pickles. I have no idea why they picked those names. They're kind of weird, but it's called cucumber testing or BDD testing. And the next one is going to be our build pipeline. So that's something else that's very important. And again, I'll show you in a minute how that works in our testing scenario. We picked this one. I kind of picked this one fairly recently. We've done a whole lot of work with the Jenkins pipeline. And Jenkins pipeline is a really great product, very, very good. And along came GitLab. Someone said, oh, we're going to be using GitLab on this new project. And I was like, oh, you know, let's reinvent the wheel. Let's do something different, do something the same using a different tool. After 6 months of using GitLab, wow, fantastic, absolutely brilliant product, extremely polished. If you're using Jenkins, then have a look at GitLab. If you're not advanced enough to have implemented a pipeline yet, then use GitLab, and I'll just show you a little bit of that at the end. And we're going to just go now and do some more interesting stuff, which is actually look at some real code. And I'm going to have to put my, because if I had this in front of me, this would be much easier, but I only have this little 13-inch monitor and I can hardly read it. So this is the old man glasses, I'm sorry. And basically we start by looking at a Docker Compose file. And this is an example of a Docker Compose file. So hands up, who's using Docker? Lots of people, way over half the people, which is brilliant. Because this is going to be the main tool we use to do any kind of integration testing is Docker. And Docker Compose, hands up who's using Docker Compose. Okay, nice to see a whole bunch of people using Docker Compose, but all you guys that are using Docker that don't know Docker Compose, have a look at it, absolutely fantastic. I'm sure you can see here all the Docker users. This is basically a definition of an image file, and this is a run-of-the-mill container that I'm going to be firing up here. For example, Zookeeper, and this is just a project. I should probably pick quicker starting containers, but we'll see how quickly it starts in a minute. So Docker Compose is a way of saying, okay, I want to start up multiple containers. And we can see here we have the Zookeeper that I want to start. I also have a Kafka that needs Zookeeper, so it's actually dependent on Zookeeper. So it allows us to define dependencies of containers. And I'm storing some stuff in a Redis database. And sewing this all together with a little bit of magic, which is Nginx. You can pick any containerized proxy, but the magic that's going on here is I'm actually declaring a local volume, and if we look in that local volume, it defines configuration. So this is this proxy file here, and if I open this up, this is basically my Nginx, which is very simplistically, in this example, has two locations, Actuator and Explore. So Actuator is Spring Boot. And it's just redirecting back to the local host. So because this is a Linux machine, there's kind of, it's not really a bug, it's a feature that's not been implemented yet, which is the Docker host machine, which is supported on Windows and it's supported on Mac. And on Linux, unfortunately, you have to use the IP address. But 172.17.01 is pointing back to my physical machine. So I'm loading a container, and if it wants to talk to my local machine, I have to give it this IP address. So this is just simply routing any requests to the actuator back to my local Spring Boot application. And this is just two endpoints. It could be any number of endpoints, and this is the magic that kind of sews this all together. And you can test this physically by running Docker up. So if I just run this Docker Compose up, it looks in that directory, finds that file, and it fires up these containers. So this is the native Docker Compose, firing up all those containers divided in the Docker Compose file. And this is just a simple way of validating it. And to shut it back down is just going to be Docker Compose down. And that will stop those containers. So how can we now utilize this? Because we want to do some testing, and we want to do this on a build server, and I actually need to test it locally, and I don't want to keep typing Docker Compose up and Docker Compose down for everything I do. And this is where the Archillion magic begins. So Archillion basically defines some rules for a test. I need to find that one. This way. It's open somewhere. There we go. So this is basically our test. And run with is the, obviously the JUnit way of saying run this test with some kind of extension. And in this case, we're going to be using Cucumber, which we just learned was the BDD extension. Oh, did I just run that already? Okay, I should go back here. So this test is defining an Archillion test class rule, and this rule is the bit of magic that sews all this together, and this loads a resource file called Archillion XML. And in our Archillion XML, we're basically saying we want to test our Docker Compose YAML. which is the definition for Docker Compose. And so taking a command line Docker Compose, I've put this now into a unit test, and I can actually run this test locally. And I didn't actually want to run that test right away, but it's running now, so we'll just go here. And part of this test is to start up a Spring Boot application. So this is the Spring Boot application test class. And if anyone's familiar with testing Spring Boot, this is just defining Spring Boot test. So the Cucumber runner and the Spring Boot test annotations basically make this test understand how to fire up stuff in my IDE, but also on the command line, and also in Maven, and also in Gradle. That's one of the goals of the Arcinium project, is not to mess up your testing experience. And so one of the first things this did was fire up the containers and run to this breakpoint. And I put this breakpoint in specifically. If I actually go and look at the location of this breakpoint, it's up here. It's just a Kafka config in my service application, which is my Spring Boot application. So in my test environment, it's very important for me to be able to debug stuff. I don't want to be disconnected. I want to be able to run to any breakpoint within my application I'm testing. And I also actually want to run to any breakpoint in my test code. So I'll let this continue. I'm going to the console, and this stuff is all firing up in the background. On the left-hand side here, you can see the BDD feature file, which I haven't introduced yet, but I'll introduce it in a second. And this is also firing up the containers. So the BDD test file itself, which is part of the test. It's difficult to move this without the mouse on here, but. I'll start singing in a minute just to fill in the gaps. So test feature. So this is a example feature file. Because we're running the Cucumber test understands it needs to look for feature files. It finds this feature file. How is this feature file going to help us test stuff? Well, in my IDE, if I just press Control and go over the code, all these lines of text, you can see there's a link, and that's a common IDE feature, and if I just click into that, you'll actually see that there's code behind this. And so now we've hit this particular breakpoint in my code, and all I'm going to be doing here is a very quick example of our REST testing. So I'm going to be calling the actuator endpoint, health, and I'm looking for a status code. And I'll run that through. So this continues, and you can see that step has passed its test. And the next breakpoint we're going to hit is another little feature that I've just introduced for the test purposes, which is basically to pause the test so I can demonstrate how powerful this mechanism has now become. And because it's my tiny little 13-inch Dell, this will take a while. So if you have any song requests, anyone? I do pretty good Tom Jones. No? Okay. So we'll just give it a few more seconds. And we've hit the next breakpoint that I wanted. So the next piece of code, I'm sorry if this is a bit large so that you can see it. Basically, the next piece of code, I've said when we can remote control the browser, and part of the Arcinium magic that was sewn into the test was to actually fire up a container that contains a browser. But I don't want the test to end, and so I've put in a little bit of a developer hack here. I'm looking for a system property, and if that's enabled, I'm just going to sit here on this server socket and wait for a curl on port 6666. So I'm just going to let that run through. and you'll see what I mean. The test doesn't end, so I don't want the test to end, so that I can demonstrate some really cool feature of this, which is, I'm going to open up VNC, and we have a browser. This browser is genuinely not on my machine. This browser is a container browser, and you can see it in the container. And part of the test was to navigate to this URL. So browser navigate to, and I'm just navigating to my CI, which is running on my local machine. And so to make that perfectly clear, this browser is an image that's provided by Selenium. So I'm using Selenium, a very familiar technology that's used to manage browser automation or UI automation. And this browser is running in a Docker container, and I'm connected to it with VNC just to demonstrate that it is there running in the background. If this was actually on your build pipeline, then obviously it's going to be running in a Docker container and it's supported. The advantage here is I'm opening a Chrome browser container, but there are various container versions. So rather than just have the browser local on my machine and have the Chrome driver that I need to manage that machine and have the Selenium server installed and all the dependencies locally, all I'm doing is connecting to a container that's been provided already. And these are official Selenium Docker containers that you can fire up. And again, there are various versions out there that you can test against. Just simply by changing in my test the system property, I can say I want to fire up against a Chrome browser, or I want to fire up against a Firefox browser or an Internet browser, Internet Explorer browser, and test my application, which is running on my local machine, but being accessed from a browser and a container on my host. And this is, full-fledged container, and I can inspect here. I could call up my JavaScript. I could put breakpoints in my JavaScript. So my test environment is also a really useful development environment because I'm firing up everything I need. So we've seen the Zookeeper and the Kafka and the Redis database and my Spring Boot application and the browser with all the JavaScript loaded in it. I can put breakpoints anywhere within my test. It's a really, really great testing tool, but it's also a really, really great end-to-end testing tool. So to complete that test, so we're hanging basically on a server socket, and all I need to do here is just do a call to localhost 16866, and did I run it? Yeah. So the connection's closed. If we go into debug, this will just basically now hit this breakpoint, which is right after the server socket. So I was just using the server socket to halt the execution of the test, but keep the runtime alive. And if I just allow that to continue now, all those containers that were fired up, they're now being shut down cleanly, so there's nothing dirty going on there. They're being closed properly. They could even contain state, so if I wanted to contain state in those containers for future tests or statistics, then I can store that. And that's the end of the test. And so what seems like something very simple, there's a huge amount of work going on behind it. So we fired up those Docker containers using Docker Compose. We've used our Killian to manage that process. We're using JUnit, which everyone's familiar with, to run the process. We're using BDD to help our product owners define our end-to-end testing. And then we're shutting or testing everything. We can breakpoint into our tests. We can breakpoint into our JavaScript. We can remote control browsers. And then we shut everything back down. And that's the test life cycle. And so there's no outside magic. So I don't need to run any steps prior to that test. I just literally run that test or debug that test, or I run a Maven clean install or a Gradle build or whatever build tool you're using. And that's pretty much end-to-end testing demonstrated in time. And we can see that VNC container has been shut down and is closed. And that, ladies and gentlemen, is basically how we do some end-to-end testing. I'm open for questions. Any questions? My mum's name? Anything technical? In fact, I can see you better without these. Sorry. Well, if there's no questions, you obviously understood absolutely everything I was showing on the screen.